Welcome to our first day of organic chemistry. In grade 11 and most of grade 12 chemistry, all we've learned about so far is inorganic chemistry. An example of inorganic chemistry would be a sodium chloride. Now, inorganic chemistry involves when you take a cation, in this case sodium, and you take an anion, which in this case is chlorine, and you bring them together. And their positive and negative charging through ionic bonding results in an ionic compound. We name those with inorganic rules. With organic chemistry, what we're going to talk about is primarily carbon-based materials. So it's going to be carbon covalently bonded to things like hydrogen, nitrogen, oxygen. Now what I've got right here on your screen, and you have this blank in front of you, is you've got the entire outline of the unit. Don't worry about copying all this out right now. What you want to focus on is this right here, because this is going to be our entire lesson today. We're going to be looking at having a lesson for every one or two of these. So we're going to talk about alkanes. Now the first thing we need to do is we need to know how we write this out. So the first example we're going to do is we're going to talk about propane. Now propane is the stuff that you're full of, is in your barbecue. And that has the formula of C3H8. So if we were to draw that out, what that means is we've got a carbon bonded to two other carbons and hydrogens all around it. Now that takes a long time to draw out, so you may not want to do all that detail. Instead, you may want to consider using the condensed form. Now how does that work? I want you to notice right here, we've got a carbon near three hydrogens. If that's the case, our first spot will be CH3. Then we've got this piece right here in the middle, where it's a carbon attached to two hydrogens. Therefore, that's going to be CH2. Finally, at the end here, you've got a carbon with three hydrogens, and that comes down to CH3. There are even faster ways to write this out. We can use the line method, and the line method for propane looks like this. Now, what does this actually mean? Well, this tip right here represents the CH3. This middle piece here represents CH2. And this last piece here represents CH3. We're going to be using all three of these ways to label them as we go throughout our unit. Now what we've got right here, this giant piece right here, is going to be the pattern we follow for all naming for organic chemistry. Now I don't want to go through every detail of the entire unit, so what I want to focus on right here today is the root. The first thing we're going to talk about the root is where we have the name for the longest carbon chain. Now, the way you can think of organic chemistry is that organic chemistry always has molecules attached to molecules. If you want to picture attaching one Lego block to another, you've got a pretty good analogy on how this works. So when we're naming the longest carbon chain, you have to keep in mind that the longest has to include all functional groups. Now the functional groups are like the Lego pieces, so whatever we name the chain, it has to include all of these pieces on here. Now if we talk about substituents, this piece right here, there are a whole bunch of things that we're going to put as prefixes before our name to help describe what we're looking at. Today all we're going to focus on is our alkyl groups.